Hey scholars, so yesterday we worked on simplifying complex expressions. Today we're going to do the same thing, but we're going to throw in some distributive property to make it a little bit harder. So for our review question, simplify the expression -4 plus 7z plus 3 minus 2z. So pause the video and try to simplify this expression on your own. Okay, so hopefully you've simplified this expression. If you need a little help, I'll help you out. I'm going to first give myself a little more room to write. So first thing I see is that I have a subtraction here, and I don't want to have it because then I can't use my commutative and associative properties. So I'm going to have to change it to adding the opposite. So I'm going to just rewrite -4 plus 7z plus 3. And instead of minus 2z, we're going to do plus -2z. Now that everything is adding and all my terms are as simplified as can be, we're just going to shape our like terms. So if I want to circle the -4, the 7z is not a like term with -4 because it's got a variable z, and the -4 doesn't. This 3 is a like term with -4, but the -2z is not. So for my z terms, I'm actually going to box them. So now we can rewrite this. I'm going to put my z terms first. So I'm going to do my 7z plus -2z. And then I'm going to add on my others. So I'm going to add my -4 plus 3. Now we can associate our like terms together now that they're all next to each other. So we can do 7z plus -2z is 5z plus -4 plus 3. -1. I can't combine it any further because the 5 has a z and the -1 doesn't. So this is my final expression. For our preview question, it just says use the distributive property to write an equivalent expression to 3 times the quantity m minus 5. So pause the video and see if you can do this on your own. Okay, so this is a good quick review of distributive property. If we would like to, which I would very much like to, change this subtraction to adding a negative first. We can do that. And now it's up to you if you want to do it algebraically or with an area model. So I'm going to use an area model, but if you just want to distribute 3 times m and 3 times -5, that's up to you. So for my area model, I'm going to set it up with 3 in the front. We have m plus -5. Draw my line down for my plus sign. Now we can just multiply it out. 3 times m is just 3m. 3 times -5 is -15. We add our 2 boxes up. We get 3m plus -15. So that's just to review our distributive property before we really kind of get going with this. If you wanted to, though, you could have just shown that everybody gets some cake, everybody gets times 3. But that is up to you. That's the other way you could have done this. So let's start looking at some of our notes. Use the distributive property to help you simplify the following expressions. So part A, we have 4 times x plus 3. So pause the video and see if you can do this one on your own. Okay, so I'm going to do an area model for this one again. So I'm going to set it up with my rectangle. I need 4 times x plus 3. Draw my line down from the plus. Now I just hit the multiply. 4 times x, 4x, 4 times 3 is 12. So this will be 4x plus 12. For our next one, part B, we have 3 times the quantity 2x plus 1. So pause the video and try doing part B on your own. Okay, this time I'm going to actually do it algebraically so we can see some more examples of that. So I need to multiply 3 by everything in the parentheses. The parentheses is my birthday party and everybody's going to get some cake. So we have 3 times 2x plus we'll have 3 times 1. Now I can simplify 3 times 2x, 6x plus 3 times 1 is just 3. So this is 6x plus 3. Part C, they want us to add 4x plus 3, which is what we did in part A, plus what we did in part B, that 3 times 2x plus 1. So we actually have two distributive property problems. We're adding them together into one big expression. So now, because we've already written out what these are when we simplify them, I know 4 times x plus 3 is 4x plus 12. Plus, I know that 3 times 2x plus 1 is 6x plus 3. So we just kind of put those together. So what we want to do today is go with just something starting with part C and getting to this second line without having to break it up into parts. If you need to break it up into parts when you're doing it on your own, that's totally okay. But our goal is to be able to just kind of get this really long expression with a couple of distributive property problems in it and then go right into solving. So I'm going to shape our like terms. So everything with an X, I'm going to circle. This doesn't have an X, so let's box it. This has an X, let's circle it. This doesn't, let's box it. Let's give ourselves a couple more lines here. So now let's rearrange so our X terms are next to each other. So we'll have 4x plus 6x, and then we'll add on the 12 plus 3. We can associate our like terms together. 4x plus 6x, 10x, and 12 plus 3 is 15. So this big long 4 times the quantity x plus 3 plus 3 times the quantity 2x plus 1 simplifies all down to just 10x plus 15. For exercise 2, we're going to write the expression 8 times 3x plus 2 plus 5 times x plus 3 in simplest binomial form. So why don't you pause the video and see how far you can get on this one on your own. Okay, so I'm going to do this algebraically. If you want to draw area models for each one, you can draw area models for each distributive property we have here. I'm going to go algebraically where I know everything in this first parentheses needs to be multiplied by that 8. So if I wanted to rewrite this, this would be 8 times 3x plus 8 times 2. So everybody got multiplied by 8 in this first parentheses. Now the second parentheses, everything's going to get multiplied by 5. So first we'll have 5 times x plus 5 times 3. So now we're going to multiply each of these terms to simplify each term. 8 times 3x, 24x, plus 8 times 2, 16. 5 times x, 5x, and 5 times 3 is 15. So now we got this into just combining like terms again. So if you needed some help to get to here, but now you can do it on your own, why don't you pause the video and try finishing on your own? If you still need help, the next thing we're going to do is we're going to circle our x's. So we're going to shape our like terms. I'm going to box this because it's a constant, circle my x, box my constant, and now we just need to sort them out, rearrange with commutative property. So I'll put my x's first, so 24x plus 5x, and then my other constants next, 16 plus 15. I can now use my associative property and associate my like terms together. 24x plus 5x is 29x. 16 plus 15 is 31. And that is our simplest expression, and we know it's in binomial form because we have two terms that we can no longer combine together. So for exercise 3, we're going to kind of practice what we did in the lesson before this when Mr. Hodge kind of messed up with that subtraction outside the parentheses. So it's going to take us a couple of steps to kind of work up to something like that. So when we have subtraction with distributive property, we need to be really careful. Practice changing subtraction into addition on each expression below, then simplify. So for part A, we have 8 minus 2 times 5. So we want to change it into adding the opposite first. So we're going to do 8 plus negative 2 times 5. Now that we've changed it, we can simplify, follow our order of operations. So we're going to do the multiplication first. That's 8 plus negative 10 which is -2. For our next one here, we have 8 minus 2 times 5 minus 4x. Why don't you pause the video and see if you can do this one on your own? Okay, so first we're going to change both of these subtractions to adding the opposite. So I'm going to rewrite this as 8 plus -2 times 5 plus -4x. So now I changed it all up. I have this distributive property here that I need to take care of before I can combine any of my like terms. So we need to multiply everything in these parentheses by -2. If you want to do an area model, you can. It would look a little bit like this. But I'm going to just do it algebraically. So I'm going to keep the 8 plus in front. That's not changing. Then we're going to have -2 times 5 plus -2 times -4x. Let's simplify each of these terms. The 8 plus is staying the same. -2 times 5 will be -10. -2 times -4x is positive 8x. From here, we can shape our like terms. So if I circle these two constants, those will stay together and the 8x will go by itself. If you want, we can rearrange it. I usually like to put the x's first. So we can put 8x plus 8 plus -10. 8x will stay the same. But we have that 8 plus -10. We'll have 8 plus -8x plus -2 as our final answer. So looking at part C, we now have two distributive properties, but we also have this minus that we need to take care of here and here. So why don't you pause the video and try this one on your own? I'm going to give myself quite a bit more room because I know I like to show all of my work. You can do area models when you get to the distributive property if you would like, but first thing I need to do is we need to take care of those subtraction signs. So I'm going to change it to adding -2 and then in the parentheses 4x plus -3. So we have two distributive property problems. You can do two area models off to the side if you would like. I'm just going to do just algebra by making sure everybody inside the parentheses gets multiplied by the number in front. So this will be 3 times 5x plus 3 times 2. So that's the first one. Plus we have -2 times 4x plus -2 times -3. So let's multiply each of these terms out to simplify them up a bit. 3 times 5x, 15x, plus 3 times 2 is 6, plus -2 times 4x, -8x, plus -2 times -3, positive 6. We can now shape and combine our like terms together. So if I circle this 15x, this 6 is a different term. -8x is a like term with 15x, and 6 is a like term with 6. Rearrange this to get 15x plus -8x, and then plus 6 plus 6. Now let's associate our like terms together. So we're going to associate our x's and associate our constants. 15x plus -8x, 7x, plus 6 plus 6 is 12. So there we go. We simplified this really long expression with this minus in front that can sometimes throw us off, but we changed everything to adding a negative and we didn't lose any negatives in the process. So that is what we're working on today. So you have some practice problems here. You're going to pick 2 of them to complete on your own. Then you're going to complete your exit ticket, When you're done with both your practice problems and your exit ticket, make sure you're going back to Canvas and completing independent practice 28.